Hi everyone, my name is Thomas Kim. Today is September 27th, 2020. This is my 63rd episode about vector calculus and classical electromagnetism. This is also my 20th episode about OpenGL graphics tutorial. In this episode, I will discuss improved 5-point stencil algorithm or numerical differentiation. We need to evaluate a normal vector to a curve or a surface in 3D space. To evaluate a normal vector to a surface, we need to find out tangential vectors at a certain point on the surface. To do this, we need numerical differentiation. Early this year, I filmed about numerical differentiation using 5-point stencil and Taylor series. If you haven't watched this video, please double-click it. I will not explain about 5-point stencil algorithm, so if you are unfamiliar with numerical differentiation using 5-point stencil algorithm, please watch this video. Now, show more. Please double-click this link. If you have this message, keep show in folder, extract it, rename 063 improved numerical differentiation. Copy, paste it in your working folder. Start Visual Studio Code. Open your working folder. Double-click 5-point.cpp. Ctrl V. Now start your command prompt. dir cd 063 improved numerical differentiation cl ehsc std c++17 5.cpp fem.exe hit enter cls m. If we scroll up in this function test diff stencil, we are calling this function. In this function, this is first order derivative of sine function. The result is here. Negative 14 means that our numerical differentiation is correct up to 14 decimal places. This value is numerical differentiation. This value is analytic or algebraic differentiation. In case of first order derivative, our numerical differentiation is accurate up to 14 decimal places or 13 decimal places. In case of second order derivative, our second order derivative is accurate up to 10 decimal places. In case of third order numerical differentiation, our algorithm is correct up to 7 decimal places. In case of fourth order numerical differentiation, it's not accurate enough. So I want to improve third order numerical differentiation and the fourth order numerical differentiation. Now scroll up, cut, paste it here, change it to constant. Also lower, copy the function, copy, paste, change it to like this. Also like this. Remove this part, copy, paste, auto F1. We are calling this function, copy, paste, copy, paste, F, n minus 1, copy, paste, 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 2, 3, 4, copy this, paste, copy this, paste, copy this, paste. It should be F1, F2, F3, F4. Now we build once again GLSM. Now our third order derivative is accurate up to 10 decimal places. It is much more improved. Also, our fourth order derivative is accurate up to 8 decimal places. So our algorithm is improved. In case of first and second order, our algorithm is accurate up to 10 decimal places. Now make it higher, copy, paste, 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 paste. Copy this, copy, paste, change it like this, copy, paste. Make it H lower, H higher. Please note that I modified default value. If n less than 3, return diff stencil lower, x, f, n, h lower. Else, return copy, paste, higher, higher. I will arrange like this. Now build again. GLSM. So when lower order differentiation, our algorithm is correct up to 13 decimal places. This is second order derivative, accurate up to 10 decimal places. Third order, accurate up to 10 decimal places. Fourth order, accurate up to 9 decimal places. Now scroll up. I don't think we need constant here. I just removed constant. Also, we don't need constant here. I will just remove constant like this. Now scroll up. Let's try with the fifth order. Copy, paste, paste. It should be 5. It should be 6. Now scroll down. In this function, make it 40. Also from here up to this point, copy, here, paste. It should be 5, 5. Fifth order, it should be 5, 5, 5, 5. 1, 2, 3, 4, 5. It should be 5. It should be 5, 5, 5, 5, 5. It should be 6, 6. Sixth order, 6. 1, 2, 3, 4, 5, 6. 6, 6, 6, 6, 6. 6, 6, 6, 6. Here, copy, paste, paste, 5, 6. Now we build once again GLSM. Sorry, it should be 5. It should be 6. We build again GLSM. So first order derivative accurate up to 13 decimal places. Second order derivative accurate up to 10 decimal places. Third order accurate up to 10 decimal places. Fourth order accurate up to 8 decimal places. Fifth order accurate up to 6 decimal places. Sixth order is accurate 3 decimal places, or 4 precisions. Using this algorithm, we will evaluate normal vector, curvature, radius of curvature, torsion, binomial vector, etc.